Okay? I about the x is 36.57. The center of mass in the y direction is, I just wrote it up, 4.8, is it? I just wrote it up there, but I erased it. So we have to shift it this way to the center of mass. What's that distance? What was the y center of mass? 4.8, right? Okay, so now let's say I about the x-axis equals I center of mass plus md squared. I'm using the parallel axis theorem. So I about the x-axis is 36.57. I about the center of mass is what we're solving for. Plus m, and then the d is 4.8. So I about the center of mass is 36.57. Oh, this is 36.57 m. Minus 4.8 squared m. That gives you I of the center of mass of that shape. I about the center of mass this way. It goes like this, and then so it's rotating this way about the center of mass. Actually, you could end up you could throw it up in the air that way because it rotates this way. You could rotate that way if you wanted to do it. Throw it up in the air like that, you know. One of them is going to give you a chaotic orbit, right? IZZ, IXX, or IYY, the medium value one. I'm thinking that this one, it's probably going to be this one. This one is going to give you a chaotic orbit. And then this one that cuts it this way is going to be the smallest. The one that's coming out of you is going to be the largest IZZ. So this one looks like it's the medium value. Okay? Okay, so that's the one. Now I can shift from here to the top axis, which is what? The distance to the top is 16. 16 minus 4.8 is 11.2, right? So I add to this, I about the top axis is 36.57 minus 4.8 squared. I add to that 11.2 squared m. And when you do that, you should get a number greater than 85.3. What? 1. Okay, good. 138.97. Awesome. We did it. We proved it. Greater than 85. So it's lovely when it all comes together and you're really getting it. You're really understanding what the moment of inertia means, how to use the parallel axis theorem, how to shift, how to do the integral, how to predict the answer. Okay, now that's quite a lot of time we spent on that. Let's now shift to how to do rotational dynamics problems once we know what moment of inertia is, how to do several different types of moment of rotational dynamics problems.